All right, so this is our new unit. It's on polynomials. We're going to go through our vocabulary. The very first definition that we're going to learn is a variable. In mathematics, in algebra, we use a variable to represent something we don't know. So we don't know the value of it. And we usually use the letter x is the most common letter to represent. So sometimes we use a variable to represent something that we can figure out, and sometimes we just use a variable to represent something we don't know. For example, you go to Dollarama, you buy two things, and it costs you $2. And you don't know how much each thing costs. Well, wait a minute. This may be not a good example because it's from Dollarama. Let's use a different example. Let's say you go to Walmart and you buy two things, the same thing, you buy two of them. Because you want, and it equals $18. So we would write that, I bought two of something, and I use an x to represent that something, and it cost me $18.
Each one is $9.
Each one is $9. You just set up an algebraic equation and solved for it, and that is 3 of our first 4 units all combined.
Nice.
It's not very complicated, but the way that we write it is we say, currently I don't know how much each of them costs, but 2 of them were $18. So then I could figure out that one of them would be $9.
8.5.
And then I figured out what my variable was equal to. That's going to be one thing that we're going to do. Sometimes you'll have things and say, well, if 2 of them cost $18, how much would it cost for 5?
A couple.
And then we'd have to figure that kind of stuff out. If 2 of them cost $18, 5 of them would cost how much?
Money.
45.
89.
Okay. So here's our first definition. Our first definition is a variable, and we're just going to use a letter to represent something that we don't know.
A or X. Guys.
Coefficient. So you might want to just leave some space for that first definition that you missed, and then you can get it later from the video. So a coefficient is a number in front of the variable. And anytime you have a number right in front of the variable, it means times. So we stop using x for times because now x is a variable. So when we have things right beside each other, like this 3x, it means 3 times x, but we don't write the times symbol. Anytime 2 things are right beside each other, it automatically means that you're multiplying them. If you write a variable all by itself, then the coefficient would be 1. So you could write a single x just like this, or if you wanted to, you can write a 1 out in front to say 1x. Here's a definition you already know. An exponent. Okay, I can go back for a second.
I know this one. Exponent is like a small. Okay, can you reject this? You can't reject this.
Can I use the washroom? I wrote this down. I'm writing at the bottom of pink paper.
Yeah, flying the porpoise from out again. Flying porpoises. Wow,
A term. So anytime you put together numbers and variables by multiplication, that is called a term. So all of these examples here, minus 3x, 2abc, negative 4xy squared, and 5, those are all terms. But anytime you have two different things separated by adding or subtracting, that makes them different terms. So a term is when something is connected by multiplication, whether it's coefficient and variables. You could have just variables or just a number. That would still make it a term. Anytime you add or subtract, that makes two different terms.
Mr. Teacher, I can't see because
So two specific types of polynomials. Basically, polynomials, which we'll get to the definition, is any expression adding or subtracting any amount of terms. But two specific ones are monomial and binomial. So notice we're studying polynomials. All these words have nomials in it. A monomial is an expression with one term. A binomial is an expression with two terms. So basically, the definition for term and monomial are the same. The definition for term and monomial are the same because a term is anything that's connected together with multiplying. And if you have only one term, we call that a monomial. If we have an expression with two terms, that's a binomial. Just like the word bicycle means you have two wheels. Tricycle. Oh.
Joseph Kraus scored his first goal since 10-1 yesterday. Give him a round of applause.
Okay.
10-1.
So here is a question for you. If a monomial is an expression with one term and a binomial is an expression with two terms, what do you think we will call an expression with three terms?
Trinomial.
Trinomial.
Quadrinomial.
wait, no, don't. Wait.
You're ugly.
There it is. An expression with three terms, a trinomial.
Is there a pentanomial?
And then after trinomial, we just use the word polynomial to say that it's an expression with one or more terms. So monomial, binomial, and trinomial are special examples with 1, 2, or 3. Polynomial represents them all.
Can we just say polynomial?
Everything's racist.
You could say polynomial every time. I mean, on some multiple choice questions, they'll say which word best describes it. And then it gives you a binomial, and your choices are monomial, binomial, trinomial, coefficient. They won't give polynomial as one of the options.
I'm going to name my kid
No!
Joe, you have to wear a cap.
Now, when we are looking at a monomial, one of the things we talk about is the degree of the monomial. And the degree of the monomial is looking at the exponent of all of your variables. And if you look at all of your variables and all of the exponents of all of those variables and add them up, that's when you get your degree. So in this first one, 3x squared, there's only one variable, and the exponent of that variable is a 2. So the degree of that monomial is a 2.
Also, can I also get a degree from murder?
In the second example, the 5p squared qr cubed has 3 variables. The variables are p, q, and r. The exponent of the first variable is 2. The exponent of our second variable, the q, even though it's not written, it would have an exponent of 1. And our exponent of our last variable is 3. If we added those all up, we would say that the degree of that monomial is 6. So I'm going to put up some examples. You tell me what the degrees are of
Polynomial. No.
Kate, I forgot about, I completely forgot. So, today I was at Roscoe.
You were today?
Today I was at Roscoe. And when I'm at Roscoe, it's like, I don't know if you remember what the street. This kid always runs when there's a person walking by.
It's in there.
He got hit by a car.
Yeah, like she's mine.
Really? Did he really get hit by a car? He didn't hit that guy. He just got up and kept on walking. But he runs like it's like a nuisance.
Ryan, you're picking our first volunteer. Who's going to answer the first blue one?
Can I answer the first one?
No, you have to pick someone.
Sarah.
Sarah.
I don't know how to do this. I'm still writing it down.
All right, so we're looking at this first one.
Okay, that's not funny.
In order to figure out the degree of 3x squared y cubed, we look at each of our variables, the x and the y, and we look at the exponents of each of them. And then it says we need to add that up.
5. 3x by 5.
So if you 2 plus 3, the degree will be 5. Cade, you got to pick the next volunteer. Julia. We look at this one, 4ABC. How many variables are there? 3 different variables, A, B, and C. What are the exponents of each of those variables? 1, 1, and 1. So the degree would be? 3. Julia gets to pick the last volunteer. You get to pick the last volunteer.
If you pick these up, you choose up.
No, I know the last one. I think I know. I'm pretty sure.
Sorry, who did you pick?
I'm pretty exact on the answer.
Caden.
Isn't it 9? No. 'Cause you have to
How many variables are there?
add the 1 to the R.
There's 4 different variables. There's the P, the Q, the R, and the S. The exponent of the P is 2. The exponent of the Q is 3. The exponent of the R is 1. And the exponent of the S is 4. So the degree of this one's going to be 10. Because we have to remember to add that 1. Can you see yourself making that mistake? Can you see yourself adding the 2 plus 3 plus 4 and getting 9 and forgetting that the R has an exponent of 1? Sometimes students like to, when they see a degree question, put a 1 up there just to help them remember to add it in. Because then otherwise it could be easy to forget it. So this is the degree of a monomial. Oh. So we figured out the degree of a monomial was just adding up the exponents of that one term. The question now is, if you have a polynomial of more than one term, how do you figure out the degree of the whole thing? Well, you look at each individual term, and then you pick the one term that has the largest degree, and that's what we call the degree of the whole entire polynomial. So in our first example here, 5x cubed plus 2x. This first term, 5x cubed, has a degree of 3. The second term, 2x, has a degree of 1. So we look for the bigger one of the two, and we would say the degree of the whole thing is 3. If we look at our second example, this first term has a degree of what? 4 plus, remember there's a 1 there. So this one has a degree of 5. The second term has a degree of 5. The third term has a degree of 6. So we would say the degree of the whole thing is 6.
Oh, okay, I see.
And the last one, the first term has a degree of?
Oh, damn.
3, 2, 2.
Which is?
7.
7. The second one has a degree of 2. The third one has a degree of 0.
Okay, I see it now.
Because it has no It has no variables. So now if we look at all three of those, which one's the biggest? The 7.
One. You're going on a trip. No, a zero.
You have $100, you're not gonna buy anything. You have $200, you're not gonna buy anything.
You got that ceramic face, Kate. You got that ceramic face. Like, look at his face. He's serious. You have Tourette.
You got that Tourette spade.
And then all my changes in Starbucks Fresh.
Kaden, you got to pick a volunteer for the last one. Sarah.
I already went. I'm out.
No, you got to go again.
Oh, Kate used to be besties on Shoal Sykes.
I don't wanna go.
No, Kate.
Pick someone else then.
Yeah, I like her.
Yes, the degree of the whole thing will be 8.
This is the biggest one there, Jay.
It's not fair. Why did she pick me? I can pick next one.
No, I was just.
So generally, when we're writing polynomials, we write them in descending order according to their degree.
I'm pretty sure I took a sleepies before this. I have a friend.
Okay, so this is 7.
So this first one, this one has a degree of 4, this one has a degree of 2, this one has a degree of 1,
Jesus!
this one has a degree of 0. That one is in descending order. But this next one isn't in descending order because this one has a degree of 1, this one has a degree of 2, this one has a degree of 0, and that one has a degree of 3. So if we wanted to rewrite that third one in descending order, we would start with negative x cubed, then subtract the 5x squared, then add the 3x, and finally put the 4 at the end.
Ben can't even spell like party, but this is a claim we already have seeded plan. Ben, all my
Yes?
I'll give credit to those paying the most attention to us.
Okay.
I just like the way that they come
So,
to each other's desks and it's over 17 days.
the next definition is constant. This definition becomes hard.
I wasn't done.
I'll go back. The,
I don't have a phone.
the next definition is constant. The next definition is constant, and it becomes a hard definition because we had an earlier definition that also started with CO. What was that definition? Coefficient. So some students get
That's what I was thinking.
constant and coefficient mixed up because the words start the same way. So how are you going to remember that coefficient is the number in front and constant is a number by itself? All right, the last definition. Like terms. This is the first main idea of algebra is centered around things that are called like terms. Two terms that have the exact same variables with the exact same exponents are called like terms. It doesn't matter if their coefficients are the same. So in other words, the number in front can be different. The number in front can be different, but as long as they have the same variables with the same exponents, they are like terms. So here we have 5x and negative 3x. Those are like terms. 4y squared and y squared are like terms. Negative 25a squared b and negative 7a squared b are like terms. Even if you wrote it in the wrong order, it would be a like term. But x squared and x are not like terms.